So, can you able to see, ma? Yes. Okay. Now we are going to learn about 8051. 8051, it's a microcontroller. Okay. Actually, this 80 always denotes that Intel manufacturer. 8085 is microprocessor. 8051 is microcontroller. What is the difference between microprocessor and microcontroller? Microprocessor, in a single chip, we have a central processing unit that is nothing but it is equivalent to register, okay, and control circuit, arithmetic logical unit. But microcontroller, we have all CPU, central processing unit, okay, RAM, random access memory. Random access memory, we have both read operation and write operation. ROM, read only memory. We have only read operation. I have input output port, IO port, timers, serial communication ports, everything embedded on a single chip. So 8051 only, one of the important thing, we have a on-chip memory, IO ports, timer, serial interface, everything in a single chip microcontroller. Actually, what is processor, what is controller? When I'm giving the example, when I'm working with my mobile, we are saying that Android processor is needed, Android is needed, Android operating system is needed. But at the same time, when I want to work with any of the system, for example, if I am buying anything, we are having a Intel core processor is inside. So one particular CPU will control the entire unit, that is microprocessor. Microcontroller, what it will be now, it is used for dedicated application. Dedicated application, for example, you go with washing machine. For the particular washing machine, I can use my microcontroller. Not for the washing machine. Even when you, during our COVID time, if I want to measure my oxygen, heartbeat and all, we have one single microcontroller chip, like quick microcontroller and all. So dedicatedly, I can use microcontroller because microcontroller having a memory also inbuilt, IO port also there, timer is also there. That's why microcontroller you can be used for some dedicated application, and the cost wise microcontroller is very cheap. But when you are going for microprocessor, depending on the mobile and depending on the laptop, we need a processor. So microprocessor, it's a whole control system where I want to connect any peripheral, everything we can connect it in peripheral. But microcontroller, everything on a single chip, that is microcontroller. So you just list out this particular PPT is available inside our drive only. So before preparing, you may go through this. 4 kilobytes ROM, read only memory. So inbuilt memory, we have only read option, not write option. 128 bytes RAM. Okay. 4-bit IO ports. 4-bit IO ports now. Port 0, port 1, port 2, port 3. 4 bits. 4 8-bit IO ports. So how many pin will come up? 4 into 8, 32 pins will be there. 32 pins will be there. Two 16-bit timers and counters are there. One serial interface. Students, you may mute yourself. Okay. Block diagram. You see, this is the, whatever I told, all are there are the block diagram. We have one oscillator, bus control. We all know data bus, address bus, control bus will be there. ROM, RAM, 2 timers, 4 IO ports I told now. P0, P1, P2, P3, 4 ports. And serial transmission and receiving. Okay. Then what are the other 8051 features? This is my architecture or internal block diagram. Only one on-chip oscillator. It's an external oscillator. Okay. 8085, how many oscillators are there, ma? 8085, how many oscillators are there? Even though it's wrong, you may answer it. 8085, how many oscillators are there? Only single oscillator are there. It is connected between two pins. What are the two pins? Study week 0 to week 4 first, students. Okay. We have an oscillator pin which is connected between X1 and 2, first pin and second pin. Okay. And how many interrupts are there? How many interrupts are there? Hardware interrupts alone. Tell me, hardware interrupts. In 8085, how many hardware interrupts are there? Trap, RST 7.5, RST 6.5, RST 5.5, INTR. 5 hardware interrupts are there. But here 6 interrupt source, 2 external and 3 internal and 1 reset. So totally 6 interrupts are there. You all understand what is the memory capacity of 8085? What is the memory capacity? What is the memory capacity? How many address bus is there in 8085? 16. I think ma'am is answering. You people, we are having a lot of work. Still, we people are being learning. You are all been a young blood. Okay, 8-bit. You all understand 8085 is 8-bit data bus and 16-bit address bus. So 2 power 16. So what is the memory? 64 kilobytes. But here we have seen that. Okay, 4 KB ROM and 128 bytes RAM is there. So I can use 64 KB external code memory separately, data memory separately. If I am having code memory separately, data memory separately, it's a separate architecture, von Neumann architecture. Okay, data memory separate, I have a read and write bar. Okay, we have external memory as a data and code. Okay, leave it first. So first you see it has also one on-chip oscillator, 6 interrupt sources, and external code memory and external data memory, code memory or program memory, data memory. We have, why we have separately? Now we can easily access. We can access the code memory separately, data memory separately. So that will increase the speed of the microcontroller. Okay, you see this is my architecture of 8051. While seeing the architecture, you see here port 0, port 2, port 1 and port 3 here. Okay, and see timing and control circuit is there. We always know that program counter will always hold the water next address of the instruction. It is common. Whatever we are seeing in 8085, that is common only. But main difference between 8085 and 8051, 8085 we don't have on-chip memory. But 8051 we have an on-chip memory. 8085 we don't have on-chip timer or counter. 8051 we have on-chip timer and counter. Okay. And another difference we can say that the frequency for 8085 is what? What is the frequency of 8085? What is the frequency, ma? Three megahertz. Okay,
3
here
megahertz.
3 megahertz, and here what is the frequency, ma? 12 megahertz. Okay, so obviously frequency increases, na? Time get decreases. Time decreases, na? Speed get increases. It's all been that. Frequency and in time are inversely proportional. When time decreases, na, my speed get increases. Okay, so you see to that in this particular diagram, we have been speaking about RAM, okay, and flash memory, program counter, timers, all the 4 oscillator, ports, port 0, port 1, port 2, port 3, oscillator pin, timer and controller. Okay. Then why I am teaching this first, Nana? Now while we are going with my weeks, we can understand well. You see, listen. Where is my pin is connected here? 18th and 19th pin, we have only one oscillator. There it is connected between first and second pin. And one more common thing is, how many pins in 8051, ma? Refer the diagram and tell me, how many pins in 8051? 8051, how many pins are there? You see the pin, what is the maximum my pin value? 40. So 8051 as well as 8085 both have how many pins? 40 pins are there. Okay, 40 pins are there. You see, I'm having 4 port lines. What are my port lines? Port 0, port 1, port 2 and port 3. Here also you see my address and data lines are multiplexed. AD0 to AD7. So you have to understand in 8085, in 8051, it's a 8-bit microcontroller. Okay, 8-bit microcontroller. I've been putting in chat. It having 8-bit data bus, 16-bit address bus, 16-bit address bus, and 40 pins are there. 40. If I'm going fast, kindly tell me. Okay. So in this, port 0, port 1, port 2, port 3. So my address bus and data bus are multiplexed. I want to separate address bus and data bus. Which signal is used here? Refer the diagram and tell me. Which pin is used to separate the address bus and data bus? Which pin is used? Same pin only we have studied. ALE. What is the meaning of ALE? Address latch enable. Used to separate lower order address bus. This is concept is same for 8085 and 8051. No difference. So see, this is my ALE pin, 30th pin. Okay. Port 0. You first learn port 0. Port 0, we all seen that port 0.0, port 0.1 to port 0.7. Okay. It is used to multiplex the lower order address by data and data bus. Okay. And port 2 mainly for a port 0 and port 2 is general purpose input output. All the 4 ports are general purpose IO. General purpose IO means it will act as a general purpose input output pin. What is general purpose input output pin? Very simple. I want to connect any LED. I can directly connect with my port 0. If I want to connect any switch, I can connect. But in 8085, I cannot connect. Very simple example, how I can explain. I want to connect my telephone line with my laptop. I cannot able to connect. So that's why nowadays we have a Wi-Fi. Previously, we have one unit modem. Still now we are having that modem. But you all know I want to connect modem. Modem will, what it will do it will act as a modulator and demodulator. What is modulator? My telephone signal is analog signal. My system is digital signal. So I want to convert my analog signal to digital signal. It will act as a modulator, modem. For example, I want to communicate only through the telephone line. My digital signal will be converted into analog signal with the help of demodulator. So I want to interface one analog signal with digital signal. We all know that A to D converter will be there. Or if I want to convert digital to analog, D to A converter will be there. So similarly, interfacing, that will be a compatible to use. So all interfacing IC also made up of Intel. All it's why we are all approving the Intel. Intel is very popular on manufacturing this type of processor. Still now we are been using. For example, my laptop I'm using Intel Core i5 processor. Even now we have an Intel Core i5 processor. Why we are learning 1970s 8085 and 8051? Because of its architecture. The 12th week assignment we will learn about the new processor. So that still we can understand from lowest processor to the new processor which is available in our market, we can learn well. Okay, if I understand the concept, even when I go with Arduino, or it may be a Raspberry Pi, or it may be a AVR microcontroller or PIC microcontroller, any microcontroller, if you know the basic, you may learn any microcontroller. That is the advantage. Okay, so port 0 to port 0.7, I am using address and data bus as a multiplex. Port 2 to 2.7, it is using as a higher order address bus. But listen, this is very important. Port 3.0 to 3.7. You have to remember. That's why I have put up some PPT for you. You need not to refer any lecture material for week 5 to week 8. You refer this particular PPT. I will share it in the group also. Okay. 3.0 for receiving and 3.1 for transmitting. INT O bar, INT 1 bar. This is external interrupt. We have studied now. How many external interrupt while we are studying? We have seen that 2 external, 3 internal. So this is the 2 external interrupt 0, external interrupt 1, and T0, T1. These are the external interrupt input timer. Using timer, we are been seeing. External interrupt 0, timer 0, external interrupt. Both are external interrupts. Okay. This is one is timer 0, timer 1. Okay. So then external data memory write strobe, external data memory read strobe. Okay, strobe it's nothing but a handshaking signal. Before, what is strobe now? You all understand we have a buffer latch. I think you see this diagram, you may understand that. I have one driver latch. Okay, so and these are the buffer pin. So always remember, my latch will always hold the data. Then it will push to buffer driver, and from the driver it will take to the buffer. So latch is nothing but a flip-flop. It can store a single storage. Okay. So while we are looking on to that, these are the thing. Okay. What is this now? IO pin we have seen. So port 0 and port 2 we are using address. Port 1 alone don't have any other function. Port 0 I am using address and data. Port 2 I am using address alone. Port 3 we have some alternate functions. That alone you learn it. Okay. And hardware structure. Hardware structure na the IO pin I told that IO pin always have a storage. Latch is having. Latch is nothing but flip-flop. Okay, here what flip-flop we are using? Refer the diagram and see what is the name of this flip-flop. I think you people have studied flip-flop in your digital. My meeting will end up in 10 minutes. Okay, if the meeting have been finished, don't worry, join in the same meeting link. What is this, ma?
Delay
What is this?
flip-flop.
D flip-flop. We are using what now? D flip-flop. Okay. Here we are using D flip-flop. Then these are the reset value of the 8051 registers. Okay. PC now, what is the full form of PC? What is PC? What is PC? Program counter. In that also same thing. PC is always program counter. ACC accumulator. P is register. PSW, please study week 0 to week 4. Okay, it's very important. PSW na program status word. SP na stack pointer. Okay. See here, there what are the registers we have seen in 8085 ma? 8085, what are the registers we have seen? Anyone can tell? What are the registers? What are the registers? I told accumulator, BC register, DE register, HL register, stack pointer, program counter, and flag register. Okay. Accumulator, I have put up in the chat. Accumulator, BC. If I use B separately, C separately, I can use 8-bit, 8-bit. Or else I can combinedly use BC, DE, HL. Stack pointer, program counter. Okay. Now you just see here I'm having 4 bank. Bank 0, bank 1, bank 2, bank 3. Why 4 banks are there now? all the 4 bank having 8 registers. See, in bank 0, have you all seen that? R0, R1, R2, R3, R4, R6, R7. Similarly, bank 1 also R0, R1, R2, R3, R0. Bank 2 also. So how they will identify this bank 0, bank 1, bank 2, bank 3? Na? In the program status word. We will see what is program status word. And you can see that, you see 00 to 1F, general purpose register. General purpose register means all banks, 4 banks are there, each bank having 8 register. So totally how many register? Over bank 8 register. So totally how many registers? 32 registers. 4 into 8. 32 registers. You see 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 7 varaikku varum. Then what is the next value? 0, 8, 9, A, B, C, D, E, F varaikku varum. Then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7 varaikku varum. Then 1, 8, 1, 9, 2, 0, 2, 1, 7, 1, 8, 1, 9, not 2, 0. 1A, 1B, 1C, 1D, 1E, 1F. So you all understand 0, 0 to 1F will be my general purpose register. 20 to 2F are my bit addressable register. You may ask, ma'am, how did I know? Na? It's all manufacturer. We have one question from 8085. Depending on each one, we have a unique manufacturer having unique registers and all. So 230 to 7F, we have a direct and indirect addressing. 80 to FF, upper 128 RAM, we have an indirect addressing only. Okay, so we have already seen that till 128 bytes RAM. Some microcontroller we have 256 RAM. But here see, they explained only from 00 to FF, 8051 and 8051A, that compatibility is there. But here you always remember we have 128 bytes RAM and 4 KB ROM. So here each microcontroller, each registers we have a address. I think that I have put up in the next slide. You see here. See, accumulator, my address is E0. B register F0. DPH means data pointer. Okay. DPL, data pointer. A82H. It is mainly to access the external memory only. We use this data pointer. This is the 16-bit register. Hachna, data pointer higher order, data pointer lower order. I na interrupt. I always stands for interrupt. T always stands for timer. Okay. S always stands for serial. Don't forget this. IA interrupt enabled register, IP interrupt priority register. You remember this internal RAM address. Port 0 to port 3, PCON power control, PSW program status word, SCON serial port control, serial buffer, stack pointer. SP is common in both 8085 and 8051. TMOD timer counter mode control, timer counter control. Here 2 timers I told, not TL0, TH0. TL0 timer lower order byte, TH0 timer 0 higher order byte. Combine this, we can say that one timer. Combine this, I can say another timer. So I'm having 2 timers. Timer 0, timer 1. Okay. So what are the things we have already studied in 8085? Na? Accumulator we studied. B register we studied. PSW, program status word. But that program status word and this program status word is different. But PSW we have learned. SP is stack pointer. So 4 things we have already studied. The remaining, this RAM address has to be, we have to study. So remember 00 to 1F is general purpose register. 20 to 2F is bit addressable register. And 30 to 7F is direct addressing and direct and indirect addressing. 80 to FF upper 128 byte RAM mainly for indirect addressing only. Okay. Then I told here what is the frequency of 8051. Now only I told. What is the frequency of 8051? What is the frequency I told? What is the frequency? 12 megahertz. Yeah, good. 12 megahertz. So you all have to remember, if any frequency is there, I have to divide by 12. That is my one machine, that is my frequency for one machine cycle. So if I want to find out the time period, 1 divided by 921.6 kilohertz. We all know time period equal to 1 by frequency. So what is the time taken? 1.085. For example, my oscillator having 16 megahertz now, 16 divided by 12 megahertz. Okay, 12. 12 means we will keep it that 12 as our machine cycle. So 1.33 megahertz, 1 divided by 1.33 na 0.75 microfarad. Okay, this is our program status word. Always I told this carry flag stands for D7th bit and P stands for D0 bit. So here what are the flags? Can anyone tell? What are the flags? CY stands for carry flag. AC stands for auxiliary flag. F0, it's available for the general purpose. And OV stands for overflow. And P stands for parity flag. Okay, parity flag is mainly indicate for the number of ones. Okay, overflow flag mainly for division and all we will use. AC for auxiliary carry. Auxiliary carry we all know, when there is a carry generated in the third bit, my auxiliary carry flag will set. CY stands for what? Carry flag. Okay. And if there is overflow in the D7th bit, my carry flag will set. And RS0, RS1, register bank. So this is one of the very important question. Why? Because na, they asked repeated weak questions from here. RS1, RS0, 00 na bank 0, 01 na bank 1, 10 na bank 2, 11 na bank 3. So listen, I think this particular meeting will be stopped less than 1 minute. So I think I will start over the meeting, same meeting once again. Okay.